Okay, so for 6.3, if we look at the product rule, remember that the product rule is that if I have uv and I take the derivative of that, then that is equal to u dv dx plus v du dx. Now, if I solve this algebraically and I get u dv by itself, what I'll end up with is u dv dx is equal to d dx times uv, and then, oops, let me clean that up a little bit. d dx uv minus v du dx. Now, if I integrate this, I have to integrate every term. So if I go to integrate this, I get that the integral of u dv dx is equal to, now remember that when I integrate the derivative of a function, I'm just left with the function. So that's just du minus the integral of this stuff, which is just going to be v du, if we want to write it that way. And so normally we don't do the x's, we just say u dv, because the x's cancel out and they use substitution. That's what your textbook writes it. So this is how we could do integration by parts. And so let me just do example number 1 so you guys can kind of see how that works or how it's applied. So example number 1 says, hey, find the antiderivative of x cosine of x dx. Actually, what we want to do is we want u to equal x, and we want to write this as dv. So what we want is dv to be cosine of x. So then that would be that du is still equal to 1, but now v is equal to sine of x. Now the reason we want that, and this is where I got kind of mixed up, is that I really want to write this as u dv, because then I can apply uv minus the integral of v du. So now when I plug everything in, I'm going to get what is the integral of u dv. That will equal u, which we said was x, v, which we said was sine of x, minus the integral of v, which is sine of x, and then du, which was just 1. Well, the integral, or antiderivative, of sine of x is just negative cosine. And so I get x sine of x plus cosine of x. And then remember on the end, because we don't have a particular solution, we don't have a point on the line or any additional information, that represents a family of functions. So we tack on the plus c.